Hey everybody, and welcome back to another fun and exciting Algebra 1 class. In today's lesson, we'll be on page number 49. Page 49, we start talking about what's called literal equations. The word literal doesn't mean literal like maybe you're thinking of. It means it's another word for letter equations. So when you see letters in the equations, and I'm not talking like one letter like we've been seeing, I'm talking about like multiple letters. Think of it like a formula. Maybe it has like two or three different letters and you're looking at it like, what's going on here? That's what's called a literal equation. So you can go ahead and look in your book on page number 49 and see about halfway down there on the page, it talks about literal equations. And so one of the biggest things we need to know about literal equations is what is a dependent and what is an independent variable. So let's look down here at my screen, and it says that literal equations are equations with letters, and they're used in formulas. So whenever you've seen a formula, you're looking at a literal equation. You just didn't know what it was called. You've seen equations before with letters in them, like a formula, like something like the length of this times the width of this gives you the area. Okay, something like volume, length times width times height. Those are all literal examples of literal equations. All right, so the dependent variable is the isolated variable. So for example, if you have volume equals or V equals LWH, that V, the one that's by itself, is what's called a dependent variable. So it's called that because it depends on what the other things are. So the volume is always length times width times height, but it depends what is the length, what is the height, what is the width. So how big is this object? What are the dimensions of the object? That changes the V. It changes the volume. Okay. The independent variable, that would be the other variables, the variables that are together, the LWH. Those are all independent variables because they don't depend on anything. I guess they depend on the size of the object, but in the question, they don't really depend on anything because they are what they are. The length is the length, and that does not change. So dependent changes based on from problem to problem. Independent is just whatever the size is of the object. It doesn't really depend on anything. You plug it into the formula and then it gives you the volume. Hopefully I haven't confused you. If I have, let me try to unconfuse you. So here's one right here. This M equals 60H. This is a formula, and this is a formula for converting hours into minutes. So for example, if I have, see, in this case, the M is the dependent variable. The M depends on how many hours, right? So if I say, how many minutes are there in 2 hours? Okay, so my H is going to equal 2. So I plug 2 in here and I get the minutes equals 60 times 2. Well, 60 times 2, you get M equals 120. And so that would be the answer. There are 120 minutes in 2 hours. So that's a formula for solving how many minutes are there in X number of hours. You could have 3.5. That would be 3.5. So you could figure out how many minutes are in 3.5 hours by doing it that way. All right, let's move on. Let's do another one. This example is in your book on the bottom of page number 49. What they tell you here is they say in this one, see, this is literal because it has an A right here, and we've never seen that before. And then it's got an X, and then it's also got a Y, so it's actually got 3 different variables. Well, which one is the dependent variable? It's the A. It's the one that's all by itself. That's the dependent variable. And these are called the independent variables, okay? They're independent and they give them to you in the question. So they say X is going to equal -4. And then they say Y is going to equal 5. Now all we do is this is just like a formula. You go ahead and you plug those numbers into it, and then you go ahead and solve it and see what you get. So we plug the 4 in here, and we plug the 4 in here because those are both x's, and then we plug the 5 in here, and that's a -4, so make sure you plug it in correctly. Go ahead and change the color here for us. So we have a equals -4 squared, and that is squaring the negative sign as well. So the negative sign is with the 4, so we have to square the -4. And then we get plus 4 times 5. So A equals, what is -4 times -4? -4 times -4 gives me negative times negative is positive, so it's going to be a positive 16. So this would be 16 plus, and then we can solve this. What is 4 times 5? And that is 20. So I have 16 plus 20, and then I add those together, and I get 36. So my dependent variable, my A, in this case, we'll call it area. I don't know if this is an area problem or not, but it could be. It would be my area equals 36. Okay. All right, and so let's go ahead and keep moving on. Go ahead and turn the page over to page number 50 in your books, page 50. And we're going to talk about the simple interest formula. Simple interest. Now, it's not simple like these problems are simple. It's just simple like basic interest formula. This is not compound interest. This is just basic, simple interest. Compound interest has a whole different formula. All right. Here it is. I equals PRT. Maybe you've heard that before. I equals PRT. It's fairly common formula that we use in different things, banking and investments, things like that. So the I stands for, and you can see it down here, the amount of interest. Interest is like not like something's interesting. Interest is how much money you make on your money when it's in the bank. For example, if I give the bank $1,000 and I leave it there for a year, they might give me $1,100 back. Why? Because I let them use my money for a year. They held on to my money, and while it was there, they paid me interest. Okay, it's this rate, it's this amount of money that the bank gives you for allowing them to use money. Now the opposite is true. If you borrow money from a bank, so you go to the bank and you say, I need $1,000 because I want to buy a new whatever. You can't buy a car for $1,000, but let's pretend you can. So you want to go buy a car and you need $1,000 to do it. Well, you go to the bank and you borrow the $1,000. Okay. Well, you don't have to pay the bank back $1,000. You might have to pay the bank back $1,200 because you borrowed the money. They let you use the money this time. But it's also called interest, whether you let the bank use the money or the bank lets you use the money. It's the same word, same name, interest. Okay, so that's what this is, the amount of interest. Next, the P is the principal, not the principal of the school. Okay, the principal is how much money you borrowed or how much money you invested. What did you give the bank? In the example we used, we gave the bank $1,000. So the principal is $1,000. Okay. The next one is the R, and that stands for the rate of interest, or the interest rate. Maybe the bank is giving you 3% interest. If it's 3% interest, then your rate would be 3%. Don't forget, we do need to move the decimal 2 places if we are using percent. Hopefully you remember that from basic math classes. All right, and then we have time. T stands for time. Now the time is how long did you let the bank use the money? 1 year, 2 years, 5 years, 1 month, 1 day, whatever it is. Now notice it says that the unit must match the rate unit. So if your interest rate is 3% per year, then this time would have to be in years. So if they give you the problem in In months, we would have to convert the months to years. All right, the distance formula. Again, this is widely used through different types of mathematics and sciences. You've probably seen this before in maybe a physical science class or something like that. But the distance formula, distance is how far something is from something else. Um, Now, the distance, this is distance and using time traveled. Like you've seen those word problems, like if this person leaves the train station at this time and the train's going this fast, how long does it take? Okay, right? They're using a variant of the distance formula to try to figure that out. So distance is a literal equation and it's d equals rt. All right, D stands for distance. R stands for rate traveled, like how many miles per hour. I was going 50 miles per hour. That would be your rate. And then T is how long were you traveling? I traveled for 4 hours. Same thing here with rate traveled and time traveled. They have to be in the same time frame. So you can't have, like, your rate can't be 20 meters per second and your time in 3 hours. You would have to convert the hours to seconds in that case. So that your standard of measurement there has to be the same, just like in the interest formula. Okay? All right, let's do one. So we want to calculate the simple interest earned on a 2-year investment of $250 if the interest rate is 0.1% per month. Now, notice that this says per month and this says 2-year. So we can do something right off the bat that's going to save us. We can go up to this and we can convert this into months. So we could say 2 years is actually 2 times 12 because there's 12 months in a year. So this is going to be 24 months. Okay, so now we're in month and we're in month. That's really important to do when you start a problem like this. Let's write our interest formula. I equals PRT. Okay, let's start plugging stuff in. What's the I? Well, that's the dependent variable. It depends on all these other things going on here. Calculate the simple interest earned on a 2-year, 24 months. So our time is going to be 24 months. Our rate, okay, is right here, and that's going to be per month. So it's going to be, our rate is 0.1% per month, okay? And then our P is our principal. So our principal was $250. So the amount we put in is our principal, and that's $250. Okay. Now what we do is we just plug it all in here. So I equals 250, and I'll put dollars, times, put a little dot there, the rate. So it's 0.1%, but we need to move that decimal point 2 points, 2 spaces. So it's going to be 0.1. So we're going to move it 2 spaces. So brute. So it's going to be 0.001. So I'll just rewrite that so it looks better. 0.001. We eliminate the percent sign. And then times, and then our 24 months. So times 24. Now, what you would do, and you can do this on a calculator. You don't have to sit there and do that whole thing. What you would do is you would go ahead and put that into the calculator. I won't take the time to do that, but you can. I'll just skip to the answer. Basically, it's just like I'm plugging it into the calculator, and I'm going to get the interest on that is going to be $6. In other words, if we take and we invest $250 for 2 years at that interest rate, we will make $6. And you might think that's not worth it. Well, it is and it isn't. So you might want to get a better interest rate. You might want to invest more money so that you can start making more money. The more money you invest, the more money you make in interest. All right, we'll go ahead and do one more. We will do this one here. This is on the top of or bottom of page 50. So find the distance traveled by an object traveling 65 meters per second for 3.5 meters. All right, so what we want to do is in our distance formula, D equals RT, we're just going to plug in. So what's the distance? We don't know. That's our dependent variable. And so the rate that it's traveling is 65 meters per second. Okay. So rate is 65 meters per second. And then we're going to multiply that times 3.5 seconds. All right. And then we are going to come up with, again, I won't take the time to do the math, and that's distance equals. So D equals, and it is 227.5 is our answer, and that is in meters. That's our measurement. And so there we go, done. Use your calculator. You will save all kinds of time. All you have to do is plug into these, use your calculator, boom, it will kick out the answer to you. We'll do one more quick. Let's do this. So we want to find the answer to this problem. So convert 68 degrees Fahrenheit to Celsius. And we're just going to plug into this formula right here. So Celsius equals 5/9 times F, which is Fahrenheit, so 68 minus 32. That's in parentheses, so we do this first. What is 68 minus 32? That gives us 36. So C equals 5/9 of 36. Or you could do 36 over 1, and this is times. So we're going to cancel 1, and that gives us 4. And that gives us 20 over 1, or 20. So our Celsius temperature would equal 20 degrees. And that is how you would solve that. And that is on the top of page number 51 if you're looking for that. So that's all I've got for you in that lesson. Not a ton there. We did several different problems, but the biggest thing, make sure you know the difference between the dependent and independent variable. Make sure that you can plug the right thing in. Make sure that your units of measurement match up, and then just use your calculator, put it in there, and it should kick out the answer to you. But make sure you get it in there right. Make sure you put the right things with the right things, that you convert when you're supposed to convert, and all that good stuff. All right. That's all I've got for you. Hope you have a good one. See you later. Bye-bye.